imagine you're given a question like this, and the question says consider a configuration of a point charge Q1 3 picocoulomb and Q2 minus 5 picocoulomb and Q3 Q4, and we're asked to find the flux through the Gaussian surface with a radius this. So on the flux phi is equal to the charge enclosed divided by epsilon naught. And epsilon naught is a constant, but for us to know the charge enclosed, we're given like 4 charges, and we're asked to like determine at what point like which charge is enclosed within this 0.5. So for us to know the specific charge, it's better for us to like try to determine the distance of each charge from this origin. So, and we should keep in mind that we're given these values, and which indicate the distance in different component x, y, and z plane. Let's try to like determine the distance of each. And the distance d is equal to the square root of x squared plus y squared plus z squared. So for d1, for q1, we have 1 0 0. That means the distance d1 will be equal to the square root of 1 square plus 0 square plus 0 square. That is 1 meters, because we are told all in meters. And for Q2 we have 1, 2, and 0, and this is for the distance 2 is the square root of 1, so square root of 1 square plus 2 square plus 0 square, and this is the square root of 5, because 2 square is 2, 2 square is 4, plus 1 is 5. That is this 5 will be equal to the square root of 5 should be approximately 2.24 in meters. Then for Q3 we were given Q3 to be 420. Q3 420. Q3 4, 2, and 0. So, and the distance will be equal to the square root of 4 square plus 2 square plus 0 square, and this is equal to 20. Square root of 20. Square of 4 is 16, and the square of 2 is 4. You sum it up, it should be 20, and this will be 4.47 meters. So for Q4 we're given Q4, that is a negative 2, 0, 2, 1, and 0 for Q4. The distance d4 is equal to minus 2, 1 and 0. So the d4 will be equal to the square root of minus 2 square plus this is 1 square and 0 square, and this will be equal to another square root of 5, which is equal to 2.24 meters. So we are asked to find, the first question is we should find the charge that is enclosed within the Gaussian sphere, Gaussian sphere, and the radius of the sphere is this 1.5. So let's go back to each of the distance we calculated, and for Q1, that is the distance 1, we are having 1 meter. So, and it's expected that it's enclosed, because if this is the original sphere, which is 1.5, then this d1 will be, the sphere will be somewhere here. So from here to here should be 1 meters. But for d2, it's already outside the sphere, so it's no longer enclosed. d3 is not enclosed as well, it's 4 meters, it should be bigger, and d2 and d4, they have the same radius. So in this case, it's only Q1 that is enclosed. So let's solve for the flux. So we have that the flux is Q enclosed over epsilon naught, and the enclosed charge is only Q1, which is 3 picocoulomb rather, and this will be equal to 3 times pico is 10 to the power 12, negative 12, divided by epsilon naught. Epsilon naught is a constant, which is 8.85 times 10 power minus 12. So, and this will be equal to 3 divided by 8.85 Newton meter square per coulomb. For the second one, we are asked to find the Gaussian surface that is enclosed within this 3 meters. And from the calculation we got the distance, then we have assuming this is 3 meters, the Gaussian surface, assuming here is 3 meters, then 1 will be enclosed. Okay, let me draw a bigger one. Then if this is 3 meters, then this one will be enclosed, maybe somewhere here. Let's say this is 1 meter, and d2 as well will be enclosed. The radius is 2 meters. Then for Q3, it will be outside. So, and Q4 as well will be enclosed, which has the same radius. So at this point, we can say that Q1, Q2, Q1 and Q2, Q4, they are all enclosed within the Gaussian surface. So, and we have the formula for flux to be Q divided by epsilon naught, and we say that Q1, so the total charge enclosed will be equal to Q1 plus Q2 plus Q4, and this is equal to Q1 is 3 picocoulomb, Q2 is minus 5, and Q4 is minus 2, and this is equal to 3 minus 7. That should be minus 4 picocoulomb. So, and since we find the total charge, the flux will be equal to Q over epsilon naught, that is 4 multiplied by 10 to the power negative 4 multiplied by 10 to the power 12, and this one, the epsilon naught will be 8.85 times 10 power minus 12, and the total flux would be minus 4 divided by 8.85 Newton meter square coulomb. So the question C, we're asked to find the area of the Gaussian surface in P. So if the area is this, for a sphere, a Gaussian sphere, for a sphere, we have that the area of a sphere is 4 pi r squared. So, and we're told that the radius of the sphere is this, so which is equal to 4 multiplied by pi, then r is 3, which is equal to 4 multiplied by 9 times pi. 4 by 9 will give me 36 pi. So, and this in meters square, this is the area. So thank you for watching this video. Kindly subscribe to this channel for more videos, and if you like the video, you can like, comment and share.